Hello guys, and welcome to another OrCAD X how-to video. My name is Adam, and in this video we're going to be making two new symbols. Specifically, we're going to be making a heterogeneous split symbol, which is basically when we take a large component and split it into multiple views, or it doesn't even have to be a large component. In this case, we're going to be taking a operational amplifier and splitting each of the functional parts into its own symbol. And then the second part that we're going to be making is a converted view symbol, which basically means that it's going to be the same symbol with just a slightly different alteration to maybe the pin configuration, or where the pins are placed, for the simplicity of placing the component and making it look nice in a schematic. Now, in my component explorer, I've already created two components: the MIC 5205 linear voltage regulator, very common part, especially if you're familiar with things like the Arduino. And then the second one here is the LM324 general purpose operation amplifier. Whenever I'm prototyping, this is kind of the first operational amplifier that I always throw in, see if I can get it to work, and then maybe worry about getting a more advanced operational amplifier. So I'm very familiar with this part. But let's go ahead and start with this MIC 5205. This is the one that we're going to be making a converted view part for. Now, what does that mean, converted view? First, let's go ahead and make the part. It's going to be our MIC 5205. It's going to use the reference designator of U. And then we want to check this option at the bottom here called Create Convert View. What this means is that we want to have an additional view for this symbol that we will use to, for example, reorient the pins, maybe turn the part on its side. Or in this case, what I like to do, when I have something like a voltage regulator or an ASIC, oftentimes the first view I will use for organizing all the pins just like they are in the physical package. So pin 1 on the top left, the last pin on the top right, and kind of going in the counterclockwise direction around the package. Now, what I use the convert view for is when I organize the pins in a more functional manner, meaning I'll have my inputs on the left side, outputs on the right side, maybe power pins towards the top and ground pins towards the bottom. In my opinion, it makes the schematics look nicer, and it's also a little easier to connect to, especially when you take this approach of all the inputs on the left side, outputs on the right side. It makes the schematic flow really nicely. So we're going to go ahead and check this Create Convert View. If you forget to check this, don't worry, because there is an additional way that we can enable this once we create the part. And then we're going to go ahead and leave the rest of this multi-part package as is. All right, so here's our part. Now I have the data sheet off here on a second page, and I will ask my editor to just include a screenshot for you guys of what I'm looking at. But the basics of this part is we have 5 pins, and it goes on an LM324 package. The pins are as follows. Let me go ahead and place pin. The name I'll just keep as A right now. That's pin 1. We're going to let's use the long lines. And the type we'll set, in a second. Let's go ahead and hit OK. Place 1, 2, 3, 4, 5 pins. And we'll jump into our edit pin table here. So our pin 1 is called in. Pin 2 is our ground pin, GND. Pin 3 is an enable pin. Pin 4 is our bypass. And pin 5 is our output pin. I'm gonna go ahead and copy this information and, maybe we just retype this GND, enable, bypass, and out. All right, before I get too far. All right, so we have added 5 pins. As I mentioned before, if you forget to create the converted view, here's where you can, in the properties panel, either delete the converted view if you already have it, or if you need to add in converted view, you can do it through here. When I go into the edit pins table, we have this additional column here called Convert View Pin Name. So when we have the additional view of this component, what is the pin name that we actually want to use? Now, in most parts, this is probably going to be the same as the normal view pin name. However, another way that you can think of this is if you have a microcontroller that has, 15 alternate functions for a pin, and you're only really planning on using one of those, maybe a GPIO, why not just use the converted view to simplify those pin names? Right, so there's a lot of uses for these converted views, and once we actually finish going through and creating it, hopefully, your brain can start brainstorming some cool ideas for other converted views. All right, so our pin numbers are correct as needed, and the only thing we want to change here is the pin type. So our input is going to be actually a power pin because this is a power input. Ground pin is a power. Enable is an input pin. Bypass we're going to leave as passive, basically just bypass with a capacitor straight to ground. And then the output is, of course, an output type pin. And then the convert view pin type, we're gonna copy that. So there's power, power, input, passive, and output. Press OK. All right, so before we jump into our converted view, let's just take a second and make our current symbol look a little nicer. I personally like to space my pins at least 2 from the edge, the top and bottom edge, and then have at least 4 grid spaces of separation between them for things like this. But if we need to fit a couple more pins, especially for this type of symbol, then 2 grid pins or 2 grid separation is, in my opinion, plenty. All right, so for this symbol, like I said, we've organized all the pins in counterclockwise order where we have pin 1 on the top left and pin 5 on the top right. And then we go in counterclockwise direction from pins 1 to 5. All we need to add here is now just a rectangle to outline our component. And it's pretty much good to go. However, if we were to need to connect this component, we have this really awkward ground pin, at least in my opinion, it's kind of an awkward ground pin that kind of gets in the way, right? So if we have our input that would go from left to right, our ground would have to connect down to here to a ground symbol, and then you have this enable that usually wants to connect also to the input pin. Start crisscrossing wires, you can get in some confusing wiring that maybe makes sense to you, but if someone else is reading your schematic, well, for them it might be confusing. So let's go ahead and jump into our converted view. Now to do that, in the bottom left corner here, click on this dot convert, and you'll notice that we have a brand new symbol with all the same pins as when we started in our normal view. So I'm also going to expand this out a bit, and we're going to move these pins in a more, what I would call functional, arrangement. So we'll put the input here on the top left, and then we'll put the enable pin right below it. And then we'll keep the output, the bypass, and the ground on the right side here. We're going to actually separate these out by 4 pins. Again, how you ultimately choose to organize this is up to you. Just because I have my own standard of how I like to connect these pins doesn't have to mean that you use that standard. But to me, if I start connecting the inputs here and the enables, that makes kind of logical sense. The output, which is probably going to have some capacitors, bulk capacitance on the output pin, those couldn't connect directly to ground or this ground pin here. And then if we have a bypass capacitor, then we can place it right here and then again connect it directly to this ground. So let's go ahead and place our rectangle. There we go. End mode and save our part. Now, if you've done anything wrong in the naming of the pins or the numbering, this is normally when you would see an error message pop up. So if you do, make sure to fix those error messages before you get, before you attach the component, the symbol to your component, or before you even place it on your schematic. So we're going to jump back into the Component Explorer and edit this part which I created earlier. So I already input some information here. We have the part number, simple description, There's my footprint. And now all that's left to do is to attach that symbol. So in the library symbols BB, here is my MIC 5205. Go ahead and check that and click attach. And in the component editor, you'll notice that we now have this option to view either the normal symbol or the converted symbol. So let's go ahead and save that and place the part on our schematic. So I'll choose this MPN here, click place, and here is my component, MIC 5205, and then this here isn't just an additional, I believe, property which I include. Or alternatively, I can click on this converted view and then click place, and we should have my converted view. All right, so when you place the part, by default in Component Explorer, it looks like right now it's not selecting the converted view. What you can do instead is when you're on your schematic and you have this component, you can do a right click and then select Edit Properties, or you can double click on the component and it'll bring up the exact same property editor. Now there's this column here called Graphic, and you'll notice that right now it's set to MIC 5205.normal. Simply click on that and change it to Convert. Close the property editor, say Save, and say Yes. And there we go, we have our converted view for this component. Now again, how you decide to use the converted view is up to you. In this case, if I were to connect an input wire here and then connect this to ground, you know what, let's actually zoom in a little and make sure that we're connecting to the right pins. All right, so if I were to actually connect here to the wire and ground, let's say that we have a ground symbol towards the bottom here, and then this enable pin has to connect to, the input here. Again, this is where you start to crisscross wires. But this symbol, which I created, it simply connects. I just realized that my snap to grid is off. There we go. Let's make sure these are on the grid. It'll be a little easier to connect now. There we go. So if we have an input to a power symbol here, the enable will connect directly to here, and then the ground will connect to a ground symbol here, and then the output will go in this direction. To me, this is a much simpler connectivity, but again, use your own ideas. Maybe you have a better way of organizing these pins. Whatever standards you might be using, go ahead and keep using those. All right, second part of the video is how to create a heterogeneous symbol. So in my Component Explorer here, I have this general purpose amplifier LM324. Let's go ahead and create a symbol for that. So I'm going to right click on my library, new part, LM324. Again, the reference designator is U. We're going to keep the PCB footprint empty. And I actually don't have a PCB footprint in my Component Explorer yet, because one of the future videos is we'll be making the 14-pin SOIC footprint in the Presto layout editor. But what we care about here now, since we're making a heterogeneous part, is we want to set the option here for the package type to heterogeneous. And then the parts per package, let's set that to 4. Because the LM324 happens to have 4 amplifiers on it, and a single power and a single ground pin that is shared between those 4 amplifiers. Now, the reason we're not doing a homogeneous pin is I only like to have those power pins on a single one of the symbols, rather than having all of the symbols be essentially of the same looking. To me, it just makes more sense. In 9 times out of 10, I'll create heterogeneous parts. Very rarely will I use homogeneous, but maybe we'll make a video on those in the future. All right, so heterogeneous part, the easiest way to kind of tell if you're making a heterogeneous part is in the bottom here. You'll notice we have symbols A, B, C, and D. If you typed in that number incorrectly, in the properties here, you'll see a section count and it says 4. You can change that to 3, 5, 6, whatever you might need, and then just go ahead and hit apply. to apply those changes. Now again, a heterogeneous part means that we're splitting the pins into different symbols, and they don't exactly have to be the same function pins, nor does our symbol have to look the same between the different sections. So what we're going to do is actually create 4 different operational amplifier symbols, the standard triangle symbol. And the first symbol is going to have our power pins, which if I look at the datasheet are pins 4 and 11. 4 being our VCC plus and 11 being our VCC minus. All right, so to get started, I'm just going to start adding some pins here. Now, again, I'm going to be very rough with how I add the pins and how I number them, because I always like to use the edit pins form to then reorganize, rename, renumber the pins as necessary. So we're going to start with pin name A, number 1, and we'll leave these all as type passive and the shape as line. Let's go ahead and hit OK. And again, I said the symbol 1 is going to have 5 pins. Symbol 3 is going to have 3 pins. I'm sorry, symbol B. Symbol C, wherever it might be, there it is also going to have 3 pins. And then finally, symbol D, place, pin. This is going to be 12, 13, 14. All right, so let's jump back to symbol A. We'll hit our edit pins table here. And again, what we need to look at is usually the data sheet, which will let us know which pins correspond to which function. So pin 1, we're going to rename it here, is our 1 out. And you can see that's already on section A, right? So our pins 1 through 5 are on section A, 6 through 7 on section B, and so on. We can just keep going through and renaming these. So 1 in minus is pin 2, 1 in plus is pin 3, and VCC plus is pin 4. Now the 5th pin, which I want on this symbol, is actually pin 11, and that's VCC minus. Like I said, that's pin 11. So what I need to do actually here is just to make sure that I change this pin number later, because right now it's pin 11 and we can't have 2 pins being pin 11. But let's just keep going through the rest. So my section B is going to be 2 in plus, 2 in minus, 2 in minus, 2 out. And then section C is going to be 3 out, 3 in minus, 3 in plus, and section D finally is 4 in plus, 4 in minus, and 4 out. All right, so this pin 11 here does change up my pin numbers, again, based on the data sheet that I'm using. So 2 in plus is now 5, 2 in minus is 6, 2 in 7 is 7, 3 out is 8, 9, and 10. And then this is still correct, so 12, 13, 14 for our 4 in plus, minus, and out. All right, really quickly, I'm just going to change the pin types here. So we have out, in, and then VCC is our power pin, and the VCC minus is also our power pin. 2 in plus input, 2 in minus input, 2 out is an output. Then we have 3 out, that's also an output. And then these are input pins, and input, input, and output. All right. So there are duplicate pin numbers in the package. Do you want to continue? Yes. Let's just double check what we messed up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think we're good. That error may have shown up because we earlier had some duplicate pins. So worst case, just double click your edit pins form, hit OK, and if you don't see any errors, you're pretty much good to go. So the last thing left here is basically just to make the symbols for each of these sections here. So A, B, C, and D. So operational amplifiers, kind of standard to have the power and ground on the top, or the VCC plus, VCC minus on top and bottom. The input and output pins are as such, where you have the inputs on the left, so your non-inverting input, your inverting input, whether these are on top or bottom, kind of depends on what you're designing. And then you have your power pins, so VCC plus, VCC minus, like I said. These are going to have to connect to a triangular symbol, which we're going to go ahead and draw here using the line tool. There we go. Now my in plus and in minus pins look okay. I'm just going to go ahead and adjust these pin names here really quickly so that they're easier to read and in a nicer location. And then finally, I also want to change the, I want to add some lines here just to connect this pin to this triangle symbol that I created. So using the line draw, we're going to add 2 simple lines just like that. All right, I'm also going to move the reference designator and the value to this bottom left corner here. And let's just also go ahead and rotate these pin numbers so that they're easier to read. All right, now I promise that symbols B, C, and D are not going to take as long to create. Simply what we need to do here is use the Control click to copy this triangular outline. Click Control C on our keyboard, jump into symbol B, paste this, and reorganize our pins on symbol B. Done. Symbol C, paste, oops, organize the pins. Ooh, okay, sorry. Output goes right there, input goes there. And move this over to the left just a little bit. Let's make sure I didn't mess up symbol 2. That looks good. And then symbol D finally. There's the output, and move the label over. And that's it. So we've created our heterogeneous symbol. Now again, the reason it's heterogeneous is you'll notice my pin 1 is actually quite different. I'm sorry, symbol 1 is quite different from what symbols B, C, and D look like. And if you ever want kind of a zoomed out view of all of the symbols in your part, you can go into View, Package, and here you can just kind of see all of the different symbols that you've created. So here's my A, B, C, and D, as well as the pin numbers that we've assigned to them. And if you want to edit a specific one, then just go into that symbol view. So I'm going to go ahead and close this package view and go to symbol A and maybe make adjustments as needed. All right, let's assign this symbol to this component, and we're pretty much done with the video once we do that. So there's our LM324. Again, we have this nice preview of the different sections in our symbol. We're going to attach that, save it, and let's place it on our schematic. Right click place. And you can see that because we have 4 parts, U2 now has part A, B, C, and D, which automatically get incremented when you start placing those components, right? And we can easily start, wiring this as needed. Maybe the, the output of this is connected to the second non-inverting input, and these just act like regular parts on your schematic. But again, these 4 symbols together make one whole physical package. All right, so I blabbed a lot in this video. Thanks again, guys, for watching. Hopefully you learned something new. And if you have any questions, comments, or concerns, feel free to leave a comment below in the video. Also, if you have any ideas for future videos that we could make, please leave a comment for us below. or anything that you'd like to see from our video team here. In the next video, what we're going to cover is, I believe we're going to look at how to most efficiently make symbols for things like FPGAs or complex ICs that might have hundreds or even sometimes thousands of pins, which can really be a painstaking process. So look forward to that video. Again, thanks for watching and see you in the next one.